A point on the terminal side of an angle theta is given. Find the values of the 6 trigonometric functions. And the point we're given is -3, -5. So we want to start off by making a sketch of this point. All right, and the point's at -3, -5. And then we're going to use that point to draw a right triangle, and you're going to want to make sure that you use the x-axis as one of the sides of the triangle. That way the angle theta will be a reference angle coming directly from the x-axis. And no matter which quadrant your point is in, you can always create a right triangle, okay, with a theta. So no matter which quadrant your point ends up in, you can draw a right triangle where one of the sides of the triangle is the x-axis, and the theta is the reference angle coming down from the x-axis. Alright, so now we're going to come back to our triangle, and we're going to label the pieces of our triangle. We had -3 for the x and -5 for the y. Now we can use the Pythagorean theorem to find the missing hypotenuse. Alright, so we're using the Pythagorean theorem. We're going to have 3 squared, -3 squared plus -5 squared equals h squared. Okay, where h is our hypotenuse. And then we've got 9 plus 25 equals h squared. So 34 equals h squared. Taking the square root of both sides, square root of 34 equals h. So the hypotenuse is square root of 34. Alright, so now we're just going to use SOHCAHTOA to find the trigonometric functions. So we know the sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So now we can say that the sine of the angle equals our opposite. So the sine is 5 over square root of 34, but we cannot have square roots in the denominator like this. So in order to rationalize this, we're just going to multiply the numerator and the denominator by square root of 34. And that gives us that our sine is equal to -5 square root of 34 over 34, because square root of 34 times square root of 34 gives us 34. In the same manner, the cosine of the angle, the cosine is adjacent over hypotenuse, so that gives us -3 over square root of 34. And again, we have to rationalize that by multiplying by a square root of 34, giving us for our cosine -3 square root of 34 over 34. And then for the tangent of the angle, we have O over A. O over A is -5 over -3, which gives us +5 over 3 for our answer. Alright, and now let's find the inverse. The cosecant is the inverse of the sine. So when we flip this one, we're going to have the cosecant. When we flip cosine, we'll have the secant. And when we flip tangent, we'll have the cotangent. So instead of being O over H, this is now going to be H over O. So H over O is square root of 34 over -5. So flipping that, and actually I can just look right here where I have it written down and just flip it down here. I've got, then for my secant is A, instead of A over H, it's H over A. So H over A gives us square root of 34 over -3. Oops, there it is. And then for our tangent, for our cotangent, the angle. We can flip the tangent. Okay, we're going to have negative 3 over negative 5, which is 3 over 5. All right, and that is how we do this problem.